Equilibrium of rigid bodies is our new topic. Please don't forget to subscribe to the channel. Okay, let us start by defining what rigid body is. This is one in which the distances between its various parts remain fixed. For rigid bodies to be in equilibrium, there should be no resultant force and no resultant moment. We have seen that we can be having when the resultant force is zero, but when there is some moment about a couple in the cases of couples. But now here, for a rigid body to be in equilibrium, no resultant force, no resultant moment. As simple as that. Let us see the three force problems. If a rigid body is in equilibrium under the action of only three forces, then these forces must be either concurrent or parallel. Let us now recall the Ramain's theorem. Ramain's theorem, we covered this already. The video is already. You can go in the playlist and then search out for Ramain's theorem. But we are going to apply it here in some cases. If PQ are forces acting on a particle in equilibrium, there should be three forces, and those forces are in equilibrium. Then it says, if these are the three forces, it says that P over sine of the opposite angle is equaling to Q over sine of the opposite angle, alpha, equaling to R over sine of the opposite angle, beta. So that's how we state Ramain's theorem. I think we have seen it already. You can visit the playlist and then look out for Ramain's theorem. General method. The following are the steps employed when solving problems of rigid bodies in equilibrium. This one is a simple form of equilibrium. Interpret. These are the things now you have to do when you're having problems of rigid bodies. Interpret the given information and draw an appropriate sketch. We are going to say how to draw them. Indicate clearly all forces, as we've seen that all diagrams requiring the use of forces, we have to indicate direction of those forces on the body in magnitude and direction. Take moments about the stable points. Now, these problems, the point where you have to take moment, it should be the easiest to handle to use. Because when you take moments at very bad points, the solution is going to enlarge. It's going to become, the process is going to become long. Okay. Resolve forces in two perpendicular directions. Okay, these are the four steps that we're going to do. Let us note, at a smooth point of contact, there is a reaction, normal of the surface, that's one. Two, at rough point of contact, there is no reaction and a friction. So, as long as there is a contact, we are going to be having reaction. Then, if it's smooth, no friction. When this is if it's rough, then there is some friction. We are going to see how do you see where friction is going to be acting. When a rigid body rests against and over the surface, say a peg, I think people know a peg. I'm going to show you in the next lesson what a peg is. The reaction to the rigid body is perpendicular to the peg. When the rigid body rests against and over a rough peg, a peg looks like this. This is how a peg looks like. Or an edge. So this is what we are talking about. When something rests on it and the over rests on it and then over. That's what we are talking about. This means when a rigid body rests against and the over sits over the surface of the peg, the reaction to the body is perpendicular to the peg. So if this is the peg, the reaction is going to be perpendicular. That's what we are talking about. To that point of contact between the surface and then between the body and then that peg. If the rigid body rests against and over, this one is rough. Whenever you hear the word rough, what do you expect? Some friction. There is a friction and the reaction at the point of contact. We have explained that. When a rigid body is hinged on a surface, there is a reaction force having components in two perpendicular directions. Okay, we are going to see all these diagrams in the next lesson. How we put the reaction, how they put friction, depending on where the thing the rigid body is going to slide. A point where moments are taken simplifies the problem, as I told you here. The point where you are going to take your moments from is going to give you either a simplified solution or a lengthy one. The best directions in which to resolve forces include horizontal and vertical directions, then parallel and at right angles to the surface of the inclined plane. So that's it. We are going to see now the basic of ladder problems in the next lesson. See you there.